Hello and welcome. I'm Karim Al-Hattab, an application scientist at TA Instruments, and today I will show you how to use TRIOS software to control thermal instruments, analyze data, create overlays, generate reports, and perform statistical analysis. In today's software demo, I will be using DSC 2500. However, other Discovery thermal instruments can be used in the same manner. Once TRIOS is opened, this interface will be displayed. You can open TRIOS by clicking on the TRIOS logo on the desktop. TRIOS is user-friendly that controls the instrument and analyzes the data. On the right-hand side of the interface, you have the control panel, and the first section here displays the instrument status and the cell temperature, then real-time signals from the instruments. Then second is the general tab, which has temperature and a gas section. In the temperature section displays the flange temperature and the DSC cell temperature. Also the cooler type, which is RCS90 here, and the RCS90 has a temperature range between -90 to 550 Celsius. The standby temperature, also you can change the standby temperature from here, and you can turn the cooling system on and off from here. In the last section, this section displays the gas purge to the cell and the base purge. Also you can change between gas 1 and 2, and you can change the flow rate from here. Then the Autosampler tab, that's the tab where the autosampler can be controlled. So you can open and close the lid, reset the autosampler, load and unload the sample and reference bands, go to the tray configuration. So almost everything you can control it here for the autosampler. Then up here we have other tabs. So first is the experiment tab, and here you can see what instrument you're connected to. Here we're connected to DSC 2500. Then the setup view, that's actually the current view in the middle here. You can start and stop the experiment, and there is the guided methods here. There are multiple tech tips on TA website that explain the guided methods in detail, and the guided methods is actually an instructional framework that helps new users to set up experiments and get the results they need with minimal training. Then the help menu. The help menu has a lot of beneficial information, and you can search for a specific topic by keywords. Then the second tab here is the instrument tab, where also you can open and close the lid, shut down the instrument. Then you have the options and the tray configuration. The tray configuration we use to add reference bands, and I will show you this in a minute. In options, you have access to several things, but for instance, if you go to the general tab, you can change the exotherm direction, the heat flow mode, and the lid type. Okay, also you have access here to the temperature standards and heat capacity standards. And there is a tick tab on TA website that shows how to add a new standard to TRIOS software. Also under application here you can go to the units. You can change the units and the digits after the decimal from here. Another thing you can do from the options is through the keys tab you can add the add-ons keys. For instance, you can see the autopilot tabs here, and this is actually so the autopilot is an add-on to TRIOS. It allows you to automate your workflow. So if you have a routine or repeatable workflow, you can write scripts for a specific workflow that you can then apply automatically. So now we'll go to the left hand side. Here we have different tabs. We'll go through them. Where the first tab is the experiments tab, where you can set up an experiment. To set up a new experiment, click on create new runs. And then the first section, you can add the sample information. So for instance, the sample name, right, and then the pan location in the tray, in the Autosampler tray. So you have 54 position in the tray, so that's the location of the sample pan. Then the sample mass, you need to input the sample mass and the pan mass if you're using the T4P heat flow mode. If you're using T1 or T4, you will need to input only the sample mass. Then you will choose the reference. So we have some references here. However, if you want to add a new reference pan, you will click on edit tray configuration from here or from here. Once you click on that, you'll have the 54 positions. So for instance, if we want to add a new reference pan in position number 1, click on position number 1, and then a new row will be populated here. Then because this is a reference pan, so it doesn't have a sample, so the sample mass is 0, and then we'll put the pan mass, for example 52 milligrams for a T0 aluminum pan. Then we close this view. Here we'll choose 1, then 1 has like the pan mass 52 and it's T0 aluminum. Then you can also add the operator's name, project's name, and any extra notes, and where you want to save the file. Then the procedure section. There are some templates here, or you can go to custom. If you choose custom, click on edit, then you'll have access to all the segments that you can use in the method. So for instance, if you want to just put create a heat cool heat, can simply add equilibrate, for instance -50, then ramp 10 degrees per minute to 200, ramp again to -50, then to 200. We click apply, and that's simply a heat cool heat method starting from -50 to 200. So equilibrate at -50 goes up to 200 at 10 degrees per minute, and then cool down to -50 at 10 degrees per minute. Then the second heat 10 degrees per minute to 200. Then there are some other options down here. The advanced one, the load window, that's the temperature at which the instrument will load the pan into the DSC cell. So by default it's the standby temperature, which is 40 degrees, but if you want to change that, you can just uncheck this and put the other temperature. The end of test option, if you want to discard the pan in waste bin at the end of the test. If not, the autosampler will put it back to the original location. And then use a standby temperature. That means after the experiment is done, the DSC cell will go back to the standby temperature. Again, you can change that by unchecking and put the other temperature you want. And then calibrations, use default calibrations. If not, you will need to choose a specific calibration. Lastly is the analysis and reporting. So you can apply a specific analysis template, report template, or send those results to a control chart. That means once the experiment is done, for instance, if we want to apply analysis template, and I will show you how to save analysis template in a little bit. You just check the box beside the analysis template and then load the template, and once the experiment is done, the analysis will be applied to this data. Here, because we added a reference on the position 1, it gives us error because we cannot put a reference and the sample pan on the same location. So if I change this, will be good. And once you input the sample mass and pan mass, you'll be ready to start your experiment. From here, or if you go to experiment, you click start, and the experiment will start. So next is the history tab. The history tab is a table. It's a table view that contains a record. Yep, as you can see here. So is a table view that contains a record of all TRIOS data files on the computer. And it listed those data files by name, and also you can check if the file has a project name, you will see it here, comments, the operator name, and date, and other things related to the experiment, like what instrument, where it was saved, and all this information. You will see it here in the history tab. Also, you can search for a specific file, but by keyword here, or by date. Next is the results tab, and that's the tab where we can analyze our data and generate reports. I already opened 3 PET files. So when you open a new data file, a new tab will be generated up here. So for each data file, you'll see a tab, and then in each tab here, you will see other 3 tabs down here. The first one is the thermogram. The second is the data collected, but in a table view. So it's the same data in the thermogram, but in a table view. And also you can export this as an Excel spreadsheet. Then the third tab is the run tab, which has all the sample information and the method information. So for instance, the sample name, the location of the sample pan, the reference pan, sample mass, pan masses, and the method used. So going back to the thermogram. So with the thermogram, we'll use mainly the analysis tab and the format tab. So to analyze one of the transitions, there are two ways to do it. First, just to select the limits, click, left click, hold, drag. Once you select the limits, you can right click, go to the analysis, and this is a glass transition of PET, so we'll select glass transition. Then we have the analysis here. So we have the repeat function, and so TRIOS remembers the last analysis applied. So once you click repeat, it will repeat the same analysis with the same limits. You can repeat the analysis within the same file, data file, or to another data file. So if I want to repeat this glass transition with the same limits, analysis limits, for example, on the other data file here, the PET clear. Okay, I can select the curve and then click repeat. And it will repeat the analysis with the same limits. Also, I can repeat the analysis on the same data file. So if I activate the second heat, it will repeat the analysis. So it's really useful when you have like multiple data files and you want to repeat the analysis of the same exact limits. It makes it easier. Also, the repeat function can be used in the overlay document. To create an overlay document, right click here, click new overlay document. Then you can send the steps of interest to the overlay document. Here I will use the first heat from each data file. To move it, just click on the step, hold and drag. Then I can analyze the first one and use the repeat function for the other two. Just click on PET clear and click repeat. Also PET green and click repeat. I can do the same thing for the melting. Speak integration for the melting, analyze, and then use the repeat function for the other two. Then I'll go back here, delete this. So the other way to do the analysis is, again, you will select the transition, and then instead of right click, you can go to the analysis tab and choose your analysis from here. In this case, that's a cold crystallization, so we're choosing peak integration and click analyze. So from Format tab, you can actually change the font size and color to any of the analyses. Okay, you can do the same thing on the y-axis and x-axis. Then if you right click on the analysis, go to edit analysis, you will have the option here to edit the limits, either by moving them or by putting a specific numbers at x1 and x2. In the parameters tab, you can change the baseline type from linear to zygomodial, for example. Other things, you can divide the peak. You can divide the peak. You can do special area calculations. For example, you can apply a percent crystallinity calculation. It will ask you to put the standard heat for this specific material. Once you input this, it will calculate the percent crystallinity. You can change the appearance. For example, if you want to change the line color, you can do this from here. And also you can add or remove labels from the analysis. Then there is the pass and fail criteria. This criteria is really important, especially in quality control. And by that, you will put a criteria, and then you want to see if the enthalpy of the cold crystallization, for example, can pass it or not. So for instance, we can add one here using enthalpy normalized. Then you have the option to add the type of the criteria, the minimum to maximum number, so it's a range, or a specific value, positive or negative percent tolerance, or a specific value, positive or negative tolerance. Right. So for instance, if we choose value positive or negative tolerance, okay, and then the value will be 28, and the tolerance is 0.5, so it's positive or negative 0.5. So that passes, right? Because it's 28.4 and we put like 0.5, positive or negative 0.5. So if we change that to 0.3, it fails. So now, what if I want to save this as a analysis template? So you want to save this as a template, and then you can apply it to other files. Once you're done with your analysis, you can go to the Format tab and then click Save Analysis. Then we can save the analysis here. So once the analysis template is saved, we can use it on other files. So if you go to the PET clear, the other data file we have here, we can go to the Format tab, Apply, and then this time we want to apply analysis template. Reload the template and click OK. Then template is applied here. So same analyses with the same limits. Okay, next we'll show you how to generate a report and save the report as a template, and then once it's saved as a template you can apply it to other files the same way we did with the analysis template. So let's add another analysis here. That's again peak integration for a traditional crystallization. And then now we can go to Format and New Report. You can generate new report. It will generate the report from scratch, or choose generate new report from a current view. It means it will generate a new report, but it will start the report by the current view, which is the thermogram we're seeing right now. If we click on that, notice like now a new tab is generated down here for the report, and it's started the report with the current view, which is the thermogram with the analysis. Then you will have a tokens on the right side that you can just click and drag it to the report. So if you want to add the sample information, you can just click and drag it. That's the sample information. Same thing with the procedure. You can just click and drag to generate a table with the method used. Also you can add images, logos, you can add tables, you can change the font color and size. The other thing, so if we deleted those, so you can, if you want to add specific information, not everything about the sample, maybe you just want to add sample name. In this case, we can write down sample and expand the sample and just put the sample name. So then let's add the procedure. Okay. Then we can save this as a template. Just simply go to template, so once it's saved, if we go, for example, to the PET green here, and then we want to apply the template. Once we apply the report template, because the report already has analysis in it, right? So it will apply the analysis first and then generate the report. So again, from Format tab, go to Apply. This time we'll check the report template and load it, click OK. And now we have two tabs down here. The first one is the analysis, and the second one is the report. Then the report can be saved as PDF. Just go to TRIOS logo and then save as PDF, or can be exported as a Word file. Also, for the data, it can be exported as Excel, so you'll have a tabulated data, or can export it as an image, or also save as a PDF. So the other option here is the control charts. If you want to put your analysis in a table view, or you want to do a statistical analysis, you can do so through the control chart. So first step is to create a control chart. So we create a new one. So that's from analysis, then create new. Now you have a new control chart. The second step to send these analyses to the control chart. So for instance, we have two, we have one glass transition here, second glass transition, and then two peak integrations, one peak integration. So let's send all of them to the control chart. So you can click send all. It means it will send all the analysis here to the control chart. So then we'll go to the second file and also send all. So in the control chart, you will see that those analyses tabulated. So it's either glass transitions, so we send two glass transitions, right, from PET brown and PET clear, and you can see the step name. It was the first heat, 10 degrees per minute to 290, the name of the sample, date of the sample, and the midpoint. And now also, if you want to display the peak integration, just go to the drop down menu and choose peak integration. If you want to have to do a statistical analysis for the midpoint, the glass transition, just click on the column and check the box beside the statistics, and then you will have your statistical analysis here. The last thing about applying the templates and different analysis is, in case you have multiple files and you want to apply a specific template to them, either analysis template or a report template, you don't need to open each one of them like this and apply it separately. In that case, you will do the batch processing. If you click on trace logo, you can go to batch, and here it will allow you to add multiple files from here. Click add and then load the files you want to analyze or apply the template to, and then you will choose between analysis template or report template. You will click on that and just load the file and click OK, and this template will be applied to all the files you added here. So the last tab we'll go through today is the Calibration tab. And the Calibration tab has two tabs inside it. The first one is the calibration data, and that displays the applied calibrations, so the current ones. So for instance, we have T0 calibration, which is the baseline calibration, cell constant and temperature calibration. Then if you want to apply or set up a new calibration, you can do so through the calibration setup tab. Right. So you have a T0 calibration and then cell constant and temperature calibration. So you will need to do T0 calibration, cell constant and temperature calibration to have accurate data from your DSC. However, other calibrations like direct heat capacity or reversing heat capacity, you will only need to run those calibrations and apply them if you're willing to obtain or collect heat capacity from your samples. So in that case, you will need also to apply the other calibrations. There are multiple tech tips on the TA website that show how to set up different calibration in detail. That brings me to the end of my talk. Thank you for your time.